myself Tarun Verma. As we know, many people think of math as an extremely tough subject that they cannot master, but it may be easy if you practice the sums daily. Keeping in mind, the only way to learn mathematics is to do mathematics. Let us start with the first chapter of class 10th NCERT, that is real number. Real number consist of rationals and irrationals, that is, there are two types of real numbers, rational numbers and irrational numbers. Rationals further can be divided into integers, whole numbers and natural numbers. Hence, real number system has many subsets: natural number, whole number and integers. Natural numbers are simple counting numbers. It is denoted by capital letter N. Simply 1, 2, 3, 4, 5, 6 is natural number. Including 0 in natural number means 0 plus the set of natural numbers makes the whole number, and an integer is a whole number, not a fractional number, not a decimal number that can be positive, negative or 0. It is denoted by capital Z. As given in the example, Z is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3. If we talk about decimals, there are many types of decimals: terminating decimals, repeating decimals and non-terminating decimals. Terminating decimals are decimals that contain a finite number of digits, means a fixed number of digits. If we divide 5 by 2, we get 2.5. There is 0.5. 5 is the only digit after decimal that ends the solution. Hence, this is a terminating decimal. While if we divide 10 by 3, we get 3.3333. There is a repetition of 3 and which never ends. Then this is repeating decimal. The repeating decimal are decimal that contain an infinite number of digits. For example, if we divide 1 by 3, we get 0.333, 7.689, 689 and so on. There is a fixed repetition of 689 infinite times. Non-terminating decimals. A non-terminating decimal is a decimal never repeat itself. Means if we say like this, 1.121221222, there is no fixed pattern of repetition. Therefore, we can say that the decimals that never repeats are as given in example 0.076923, 0.05882352. These are non-terminating decimals. Now, Euclid division lemma. First, you should understand that what is lemma. Lemma is a proven statement used for proving another statement. Euclid given the lemma and said that for any two positive integers a and b, there exist integer q and r such that a is equal to bq plus r. This is nothing but you can say dividend is equal to divisor into quotient plus remainder, where r lies between 0 and b. You can say 0 is less than or equal to r and r is less than b. Means r begins with 0 and always less than b. If we divide 15 by 3, we can say we have 15 as a and 3 as b. Now we can say that after dividing we have 5 as a quotient and 0 as a remainder. Then we can write 15 is equal to 3 into 5 plus 0. Next, Euclid division algorithm. Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Hence, if you differentiate between lemma and algorithm, you can say that lemma is a proven statement used for providing another statement, while algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Then, if we are tackling Euclid division algorithm, to obtain the SCF of two positive integers, say C and D, where C is greater than D, then we have to follow some simple steps. As step 1, after deciding that C is greater than D, applied Euclid division lemma and find a whole number Q and R such that C is equal to DQ plus R, or you can also say is equal to BQ plus R. For simplicity, I have given a picture on your screen. If we take example 980 and 78, where 980 is greater than D, now consider 980 as C and 78 as D. Then dividing 980 by 78, we get 12 as a whole number and remainder 44. 12 as a quotient and 44 as a remainder. Now we can write 980 is equal to 78 into 12 plus 44. Here 78 becomes C and remainder 44 becomes D. Again applying the same, we get 78 is equal to 44 into 1 plus 34. Proceeding in the same way, finally we get 10 is equal to 4 into 2 plus 2, and 4 is equal to 2 into 2 plus 0. Hence, this is we are in step 2. If R 0, D is the SCF of C and D. Then we can say if R does not equal to 0, apply the division lemma to D and R. But finally, if you get 0, then SCF is the last divisor. The fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, means prime number. The representation is called prime factorization of the number. This factorization is unique apart from the order in which the prime factors occur. This is a fundamental theorem of arithmetic. Here is also given an example. 1092 dividing with the prime number 2, we get 546. Now dividing 546 with a prime number 3, we get 182, and dividing 182 again with 2, we get 91, and finally dividing 91 with a prime number 7, we get 13. This is the exactly what the theorem says. Now higher common factor means SCF. The SCF of two numbers is equal to the product of the terms containing the least power of common prime factors of two numbers. While lowest common multiple LCM, the LCM of two numbers is equal to the product of the terms containing the greatest power of all prime factors of the two numbers. Hence, SCF, which means highest common factor, is the least power, while LCM, lowest common multiple, is the greatest power of prime factors. Now, relationship between SCF and LCM. SCF into LCM is equal to product of two numbers. This is an important formula. For example, if we have A is equal to 3 and B is equal to 6, then finding SCF and LCM of these two numbers, we have SCF 3 and LCM 6. We get, on multiplying, 3 into 6 is equal to 18. This is the product of two numbers, hence verified. Now by prime factorization 26, on prime factorizing 26 we have 2 and 13, 2 into 13, and on prime factorizing 91 we have 7 and 13. SCF of these two numbers is 13. LCM of these two numbers is 13 into 2 into 7, means 26 into 7, that is 182. Then as multiplying LCM and SCF, we get 2366. This is exactly is equal to product of numbers 26 multiplied by 91. Hence, we can say LCM into SCF is equal to product of two numbers. Now here is a question. If you are given with the SCF of two numbers 306 and 657 is equal to 9 and LCM you have to find out, then we have the formula SCF into LCM is equal to product of two number. Therefore, apply this and get your answer. For simplicity, I am doing there. Okay, if you have given LCM SCF into LCM is equal to product of two numbers, then simply you have 9 into LCM is equal to product of two numbers 306 into 657. Now divide 9 on the RHS and you get the LCM 22338. Hence, now moving ahead, we get irrational number. Irrational numbers are any numbers that cannot be expressed in the form of rationals, means in the form of a by b or p by q. They are expressed as non-terminating, non-repeating decimals, decimals that go on forever without repeating a pattern. Examples of irrational number may be 0.434334333433334. These are examples of irrational number. 45.8645, whatever given on the screen, may be the irrational number. Pi is also irrational. Root 2, root 3, root 7, root 5. These are also examples of irrational numbers. Now, things to remember, let P be a prime number if P divides A. Sorry, here should be A square. If P divides A square, if P divides A square, then P also divide A, whether A is positive integer. For example, if 2 divides 100, that is the square of 10, then definitely 2 will also divide 10. In the same manner, if 5 divide 625, then it will also divide the number. You can say that means 1 minute. If 5 divides 625, then 5 also divide 25. This is what the theorem says. And the second point, when prime factorization of q is of the form 2 to the power m and 5 to the power n, then x has decimal expansion. Which terminates, and when q not of the form 2 to the power m and 5 to the power n, then x has a decimal expansion which is non-terminating, repeating or recurring. Hence, when prime factorization of q is of the form 2 to the power m and 5 to the power n, then the number has decimal expansion which terminates and q is not of the form, then x has a decimal expansion which is non-terminating, repeating or recurring. Hence, it is saying that if your number can be taken in the form 2 to the power m and 5 to the power n, then it is terminating decimal. Otherwise, it is non-terminating or repeating decimal. as here given an example is 17 by 8 has terminating decimal expansion. How would you know? Then in the p by q you have to see only denominator part. 8 took 8 and factorize it as 8 is the cube of 2 and 5 to the power 0. As you get 8 is equals to 2 cube into 5 to the power 0. So the denominator 8 is of the form 2 to the power m and 5 to the power n. Therefore, it has terminating decimal expansion. If you consider 29 upon 343, then 343 is equals to 7 cube, and hence 2 to the power m and 5 to the n formula fails here, and hence it is non-terminating decimal. Hope you will understand it. Thank you.